By level 3 you already know Java's syntax cold. Now it's time to build the kind of backend service you'd actually ship. In this video we'll connect to a real database with JDBC, expose that data over a REST API with Spring Boot, clean up the design with a few battle-tested patterns, and then put every piece together in one full CRUD project. Every backend eventually needs to talk to a database, and in Java that conversation happens through JDBC. We'll connect to an in-memory H2 database, create a table, and see why prepared statements aren't optional. They're what keeps your app from being hacked. First, you add a JDBC driver. We're using H2, a pure Java database that runs entirely in memory, perfect for learning, with no server install required. Just one Maven dependency and you're ready to connect. Connection, statement, and result set all implement auto-closable, so wrapping them in try with resources guarantees they get released even if something throws. That's exactly how you avoid leaking database connections in a long-running service. Never build SQL by gluing strings together with user input. That's how SQL injection happens. A prepared statement treats question mark placeholders strictly as data, never as syntax, so even a malicious string trying to drop your table just gets stored as harmless text. Put it together and you get a full CRUD flow. Insert 2 employees, list them, give Alice a raise, then delete Bob. Every method still goes through prepared statement, and the result set is read one row at a time until next returns false. That's the raw JDBC layer. Connect, prepare, execute, read the result set cursor row by row. Real applications usually don't handwrite this much SQL though. They layer an ORM like Spring Data JPA on top, which is exactly where we're headed next, turning this database access into an actual REST API. With data in the database, the next step is exposing it to the world. Spring Boot lets you spin up a full web server with almost no boilerplate. We'll build a controller, a service, and a JSON response in about 5 files. One dependency, Spring Boot Starter Web, pulls in an embedded Tomcat server, Spring MVC, and Jackson for JSON. There's no separate application server to install or configure. The entry point is tiny. One annotation, Spring Boot application, turns on auto configuration and component scanning, and running main starts an embedded server on port 8080 by default. A Java record makes a perfect response body here, just 2 fields, message and ID, and Spring's Jackson library serializes it to JSON automatically, no extra mapping code needed. The service layer holds the business logic and gets marked service, so Spring manages it as a bean. Notice the atomic integer counter constructor injection keeps this class easy to test in isolation, with no static state hiding inside a controller. The controller wires it together. REST controller tells Spring every return value becomes a JSON response body, path variable pulls the name straight out of the URL, and request body deserializes an incoming JSON payload into a request record. Constructor injection supplies the service automatically. Start it with MV and Spring Boot, run, then hit it with curl. A get to /API/greet/Alice and a post with a JSON body both come back as clean JSON, with the ID counting up each time. A handful of annotations power all of this. REST controller and service are both specializations of Spring's general component stereotype, which is how Spring finds and wires the greeting controller to greeting service automatically. You never write new greeting service yourself anywhere in the app. You've now got a live REST API returning real JSON. Layer a database underneath these endpoints with Spring Data JPA and you get a real backend, exactly what the capstone project at the end of this video does. But first, let's make sure the code behind these controllers stays clean as the app grows. Before we wire everything together, 2 patterns worth knowing well: factory for centralizing how objects get created, and strategy for swapping algorithms without a wall of if statements. We'll also touch Singleton and Observer along the way. A factory hides which concrete class gets instantiated behind one creation method. Callers ask ShapeFactory for a circle or a square and depend only on the shape interface. Add a new shape later, and only the factory needs to change. Singleton guarantees exactly one shared instance. The classic version uses a private constructor and a static getInstance method, but the modern, recommended approach is an enum singleton. It's thread-safe by construction and immune to the reflection attacks that can break the classic version. Observer lets a subject notify a list of listeners without knowing anything about them beyond a shared interface. Here, placing an order fires off an email confirmation and an inventory reservation add a third listener, and order service never has to change. Strategy extracts an algorithm behind an interface so it can be swapped at runtime. Checkout doesn't care whether it's applying no discount, a percentage, or a flat amount. It just calls strategy.apply, and the right math happens underneath. Factory, Singleton, Observer, Strategy. 4 patterns, 1 goal, keep code flexible without conditionals sprawling everywhere. Now let's put JDBC, Spring Boot, and Clean Design together in one real project. Here's the capstone, a task management REST API backed by a real H2 database, with full CRUD create, read, update, and delete tasks over HTTP. This is where JDBC and Spring Boot fuse into one layered service. The task entity is a plain class annotated for JPA. Entity marks it as a database table, and ID plus generated value handle the auto-incrementing primary key. Spring Data JPA reads these annotations and creates the table for you at startup. The repository is startlingly small, just one line extending JPA repository. Spring generates find all, find by ID, save, and delete by ID for you at runtime. You never write the SQL yourself. The service layer sits between the repository and a controller. Create wraps a new task and saves it, update finds a task by ID and maps over it if present, and delete checks exists by ID before removing anything, all without a single raw SQL statement. The controller maps straight to HTTP verbs: get mapping for list and fetch one, post mapping to create, put mapping to update, delete mapping to remove. Each one returns a response entity, so a missing task cleanly comes back as a 404 instead of crashing. Start the service, then walk through the full lifecycle with curl. Post a new task and get back its ID, list it, update it to completed, delete it, and confirm it's really gone with a 404. That's a complete, working backend. The service layer sitting between controller and repository is exactly the structure real production Spring Boot apps use, and finishing a project like this means you're ready for level 4, master. That's a full level 3 backend arc: JDBC for real database access, Spring Boot for the REST layer, for design patterns to keep the code clean, and a capstone project tying it all together into one working task API. If you followed along, you basically built a small production-style service from scratch. Every lesson we covered is linked below if you want to build it yourself or go deeper into any single piece.